Thank you for joining this lesson. We're going to discuss indices, the laws of indices together with the applications. Remember to subscribe. Remember to share so that you may invite friends to this live broadcast. Yeah, this is the document that we shall interact with, and I hope you shall benefit at the end of the lesson. As we continue learning, remember to invite friends so that they may also benefit from this live broadcast. Yeah. So I'll first go through all the laws. Then after that, we'll be looking at the application of the laws in simplification of algebraic indices. We will also look at the application of the laws in number indices and also solving of indicial equations or equations which involve indices. The laws, one by one, we will be very quick because later I'll be giving examples for pertaining every law. Later I'll come with examples now for every law. So the multiplication law of indices, when the bases are the same, for example, a at a, then raised to different powers, m at n. How to solve that one? You just pick the base and you add the powers. For example, if you have 2 power 4 and 2 power 2, the solution is simply 2 because the base is the same. Then we add 4 and 2. So at the end of the day, we'll have 2 power 6. So that is how we apply such a law. Then the division law, if it is 2 power 4, then a division 2 power 2, we subtract the indices according to the law and how it has been stated. So it will be 2 power 4 minus 2, which is just 2 power 2. So that's how we apply the division law. Then there is the product law in number 3, which we call the multiple power law. Now, in the multiple power law, when a is raised to power m, then there is another general power. We usually take a multiplied by the product of the powers. A times the product of the powers. I think I must illustrate this in a better way. I must illustrate that in a better way, whereby in case you have 3 power 2, then you are told now everything has to be raised to power 3. This is a simple way of taking 3 power the product there, which gives us 3 power 6. Instead of raising 3 to power 2, then you start cubing later. You can take the product of the 2 powers, which becomes 3 power 6. So that is how we handle such a case. Then the zero index, or the power of 0 law. The power of 0 law, we call it the zero index. So the zero index says that anything raised to power 0 is usually 1. Anything or any number, any base to power 0, it should give us 1. Yeah. I will show you how such a law is applied in several questions. Then the negative power law. The negative power law, it's good for us to know that when we are having the reciprocal of a, it is the same as a power negative 1. Again, it's also has to be known that when you have a certain fraction raised to a negative power, it is the same as taking the reciprocal of such a fraction, then we raise to the positive power. This is what we mean. If we have a, actually the negative power law must be stated this way. If you have a number raised to a negative index, you can just take the reciprocal of this number, then the power becomes positive. It will be applied in several numerical cases, and we're going to see that. Yeah, we shall see that. We shall see that. Okay. Roots as powers. We call it it can also be combined with number 7, whereby we call it the fractional law. The fractional law. Because when the power is a fraction, one, either the numerator or the denominator has to become the law. And that's why we have the fractional law here, whereby we are saying, when we are told a power fraction, let's say n out of m, then we need to take m root of a, then everything now is raised to power n. Yeah. So that's how the laws are. And it's good for you to know that anything raised to power 1 remains the way it is. Any number raised to 1 remains the way it is. As we continue learning, I will also be reminding people of one of the convenient ways of purchasing airtime from your mobile phone to any network, be it Safaricom, be it Airtel, be it Telcom. Just go to your M-Pesa menu, Lipa na M-Pesa. The pay bill is 7373.56. Then the account number is the number of the phone that you'd like to purchase airtime for. Then you proceed to include the amount and you complete your transaction. Through that, the airtime is going to reflect instantly. So please don't hesitate. Use our approach and also invite your friends to utilize the same. Thank you so much. Let's continue now with the examples on indices. Simplification of algebra, or rather algebraic indices. We're going to do several here, and then later I'll be giving you time to try a few, which you can work them later or during the session. But when we look at number 1, you see we are told to simplify the expression 12y power negative 5, then divided by 3y power negative 2. Y power negative 2. Let me use the space alongside for me to work this one out. Numerically, we have 12 and 3, which can simplify to give us 4. Yeah. 12 and 3 simplifies to give us 12. Then we have y power negative 5, which is being divided by y power negative 2. This means we need to say 4 y power negative 5. Then we subtract negative 2. Yeah, then we subtract negative 2. So this is going to be 4 y power. This is negative 5, but now it becomes a plus 2 there. So the answer is going to be 4 y power negative 3. 4y power negative 3. So this is going to be the simplest form of such a question. So you have now simplified. If it is like terms, you have brought them together and you have applied the necessary powers to have them brought together. So that's how you do number 1. That's how it gets simplified. That's how simple the questions are. In this section of algebraic problems, remember we go to numerical cases and also equations, and you have to be attentive in all the settings of indices. we can look at number 2 and the appropriate law that we're going to apply. Simplify. You see now inside the brackets, we have everything raised to power 2. Then the denominator is also having everything raised to power 3. And this is to mean that for us to play along in this question, we're supposed to apply the product law in number 3. The product law in number 3, whereby we have to raise everything to power n. So in this particular case, we're going to square everything first. And 4 squared becomes 16. X squared. Then we will have y being now power 4 because it is already power 2. Divided by 2 power 3 becomes 8. X, which is to power 1, now becomes power 3. Yeah, x becomes power 3. So at this point now, the numerical part which can simplify is that by 8 we can have 1, and by 8 we have 2. So it will be 2. Then, you know, x to power 2 is being divided by x to power 3. Then there is now y power 4. At this point, we can have 2x, 2 minus 3, then y power 4. This will be 2. Then x will be raised to power negative 1, and y to power 4. This is a simplified expression. But again, a student can still move ahead to have 2 y power 4, then we divide by x. Dividing by x because when x is raised to power 1, which is negative, it can mean the reciprocal and the power becomes positive. And remember, anything being raised to power 1 will remain the way it is. So I will still be correct to argue in this manner. Yeah, I'll still be correct to have such an argument. We cannot finish this without handling a question like number 3, which is very interesting. We cannot do away with this section without handling number 3. So we're going to look at number 3 again. Remember to subscribe. Remember to share. Remember to invite a friend to Shifting Grades Online School. Number 3. Simplify the expression. The square root of 3 a power 3 bc multiplied by 6 multiplied by 6. Then we have a power 2, b power 2, and c power 3, and divided by 2a b c power 4. That is the problem that we're supposed to simplify. In this particular case, I want us to take it slowly. Remember, raising to power half according to what we have here. Obtaining square root means raising to power half according to roots as power. When we have a root as power in number 6 here, we raise it to the fraction of that root. So this is automatically square root. So everything is to the power of half. Now we can first of all combine what can be combined. For example, we have 3 and 6. That gives us let's say 18. Yeah. First on the numerator. 3 by 6 gives us 18. Then a power 3 and a power 2 becomes a power 5 because it's being multiplied. Yeah. It becomes a power 5. Then b is to power 1 and the other b is to power 2. So b becomes power 3. Still on the numerator. Then we have c power 1 And on the other side, we have c power 3. So it becomes c power 4. We divide everything by 2a, b, c is to power 4. Now, because we have a root, we have to raise this one to power half, everything to power half. We can now start combining what can simplify with another. And for 2 and 18, that gives us 9. Then a power 5 and a power 1 being divided should become a power 4. We have to divide at that point. So if we are dividing, then we subtract the powers. Now, b power 3 and b power 1 being divided should become b power 2. Then c power 4 and c power 4 should cancel because it will be c power 4 and we subtract 4. It becomes c power 0, which has an equivalence of 1 according to the zero index law. Then everything now is raised to power half. 9 to power half becomes 3. A to power 4 becomes power 2. B becomes power 1. And this one has a value of 1. So the square root of 1 is just 1. This becomes our simplest form for the given expression. The simplest form for the given expression. Here we still continuing. Again, a reminder about the most convenient way of purchasing airtime for all the networks. You just go to the M-Pesa menu, Lipa na M-Pesa. The pay bill number is 737356. Very easy to memorize. Utilize this one and invite friends and family to use the same. When you go to the account, it is the phone number that you'd like to purchase airtime for. Be it yours, be it that of a friend, be it Safaricom, be it Airtel, be it Telcom. Just enter the phone number as the account. Then you proceed with the amount of airtime that you'd like to purchase. After that, you complete your transaction and you receive airtime instantly. So thank you so much for the continued support. Now we can proceed to another format of setting. But before this, I'm tempted to show you how number 4 is done. Remember, after that, I'll be letting you now to attempt number 5 and number 6. You can even take a screenshot of this question so that later now, at a personal level, you may just continue solving out mathematics problems. So number 5 and 6, I'm giving as an assignment. Remember to work them out. Our consultation line is 07 04 15 33 66. So that is the number you can communicate any challenges through in case you get stuck in your revision. Just let us know. Yeah, those who are also managing to work out, you can also let us know that you got the right answer, and that will be very encouraging. Number 4, another interesting question. Now we're going to have everything raised to power 4 in the first term. So 2 raised to the power of 4 is equivalent to 16. So let's begin by 16. Then we multiply 16 by a power half. That half must be multiplied by power 4. And it becomes a power 2. Then we are having b power 3, which becomes a b power 12. Because 4 multiplies by the 3, which is already existing. Then we have to multiply by, because the power is negative, we're going to apply the negative law of indices, which says that we need to take the reciprocal now. So we take the reciprocal of everything and the power becomes a half. So the reciprocal of everything here, 4, a power 6, b power 2, yeah, and everything now the power becomes positive. We take reciprocal and the power becomes positive. Let's solve it. 16 a power 2 and b power 12. And now we are multiplying this by 1 out of the square root of 1 is just 1. Then 4 raised to power half becomes 2. A power 6 raised to power half becomes a power 3. B power 2 raised to a half remains just b. So it's like now we are having 16a power 2, b power 12. This is 1 over. So we are having 2 a power 3 and b power 1, of which we can simplify further now and start having the numerical part. We will have 8. Then a is raised to power negative 1 because we must talk of 2 minus 3. Then b is to the power of 11. I said this can be simplified further by having 8 b power 11 then out of a. Yeah, b power 11 then over a. B power 11 then out of a. So that is this is already a correct answer, but we can just simplify further by applying the negative law of indices. Then we take the reciprocal of a. So those are enough cases for the first type of setting, whereby we are talking of simplification of algebra. Please try number 5 and 6 at your own convenient time. Now we'll be looking at numerical indices or number indices, whereby we are applying this in some numerical cases. Then we see how it goes about. We just apply the laws. This one I'm doing ahead of the equations, which I'm also going to solve. And I now talk about number 7. Now in number 7, we are taught to simplify without the use of calculators. 4 raised to the power of 3 over 2 plus 4 raised to the power of negative half. The fractional law means for this first term, we have to take the second root of 4, then we raise to power 3 according to the fractional law of indices. Then plus, we have to take the reciprocal of 4, which becomes a quarter. Then we raise everything now to power half. This means in the first case, we have 2 cubed because the square root of 4 is 2. So 2 raised to power 3 becomes 8 plus. This is going to be 1 out of 2 because we are taking the square root now. The square root of a quarter, which is half. This is going to be 8 and half. Yeah, 8 and half. So that is the final solution in that given problem. 8 and half. Can see you're still following. Yeah, remember to subscribe. Remember also to give us your comments on the same. Please comment on the lesson. Kindly comment on the lesson. Invite friends. Subscribe and share. Number 8, which is the second problem in this type of setting. Let's look at number 8. We are taught to simplify again without the use of calculators. 8 power 2, that's multiplied by 4 power 3 over 2 divided by 16 raised to the negative power of 3/4. So we can begin by working out the numerator. And on the numerator in the first term, because the powers are fractions, then we begin by taking the third root of 8. Then after that, we have to raise it to power 2. Yeah, remember we said a power n over m. We take the m root. It's only solved by taking the m root of a. Then now everything is raised to n. So with that kind of a law, then we can apply it conveniently This one is being multiplied by, for 4, we take the square root, then everything is cubed. Divide by, at the numerator, we have a negative power. So we applied the negative law, whereby we should take the square root, the reciprocal, of 16. Then now it becomes positive power. Yeah, we apply the reciprocal, and the power assumes a positive. Let's continue working this out. The third root of 8 is 2. Then 2, when you square, we get 4. That is from the first term. In the second term, on the numerator, we will talk of the second root of 4, which is 2. Then raised to power 3, it becomes 8. Divide by, we apply the fraction law at the denominator. The fractional law at the denominator. So we have to take the fourth root of 1 over 16. The fourth root of 1 over 16. The fourth root of 1 out of 16. Then after this now, everything is supposed to be raised to power 3. Yeah, everything raised to power 3. The first case, we are having a 32 at the numerator. Divide by the fourth root of 16. The fourth root of 16. The fourth root of 16 is 2. Then 2 power 3 is 8. Half power 3, which is 1 over 8. So the fourth root of 16, because 2 power 4 gives us 16. Then it means the fourth root of 16 is half. So 1 over 16 becomes 1 over 2. Then there is power 3, whereby we cube. So it's 1 over 8. So at the end of the day, we'll be having 32. And 32 is being divided by 1 over 8. This is to mean that 2, instead of dividing by 1 over 8, we multiply by 8. So 32 by 8, this will give 256. 256. So that is the final answer in the question. The final answer in the question. Wow, thank you so much for the following. You can see you guys are really reading. We are summing up. And at this point, we can now look at the next question. Remember, we started with number 7. We have done 8. Now we can look at, people can solve number 9, which is a bit simple, number 10, which is a bit simple, and allow me to proceed to a question like, let me work, they're a bit complicated ones, like number 12 and 13. Then students will also take an opportunity. Before we go to the equations now, students now will take time to work out the remaining problems. Remember, you can just take a screenshot of this, or you get to our consultation line 0704153366. Through this number, you can request for this document so that you may see all the questions. And again, through the same number, you can organize for individualized tuitions. Yeah, to those who are having some challenges in mathematics. Let me go to number 12, a very interesting item. Yeah, number 12. Let me clear the space up here so that I may also use the same space to handle the problem that we are having. Remember to subscribe. Remember to share. Remember to invite friends and classmates and schoolmates, people who are also going to benefit from Shifting Grades Online School. Mathematics is very easy, cheap to understand. Remember, in this platform, we are also having physics lessons, and we're going to still publish more lessons. Let's look at number 12 now. Number 12, 125 raised to a third multiplied by 25 raised to a half, then plus 16 raised to 3/4 plus 64 raised to a third plus 1 out of 49 raised to negative half. Then everything is being raised to negative 2/3. So we're going to apply several laws here. Yeah, and at the end of the day, we will get to the solution. Let's begin with 125, which has been raised to power third. That means obtaining the cube root. So we start by obtaining the cube root of 125. That is the first interpretation. We multiply this by 25 raised to power half means the square root of 25. Yeah, square root of 25. Then plus now for 16, which is raised to 3/4, we need the fourth root of 16, then squared. The fourth root of 16, then everything power 3, because the power there is 3/4. So fourth root raised to power 3 multiplied by we have 64 power a third. So it means the third root of 64. The third root of 64. Then plus, we're having 1 out of 49 power negative half. At that point, we shall have 1 divided by. Now for 49, we need to take 1 out of 49. Then we raise to power. It has been raised to negative half. Now it becomes power half. It now becomes to power half. Then after this, we have to look at negative 2/3. So we have to raise everything to negative 2/3. We'll get to the negative power, don't worry. Negative 2/3. Yeah, negative 2/3. We are at that point now. I think we can continue interpreting the third root of 125 is equivalent to the third root of 125 is 5, because 5 power 3 gives us 125. Then third root is 5 multiplied by 5 again, the square root of 25. Is that so? Yeah. Then now we shall add fourth root of 16 is 2, and power 3 becomes 8, multiplied by the third root of 64. Let me look at that. We get 4. The third root of 64 is 4 itself. Yeah, 4 itself. At that point, we can now add again 1 divided by 1 over 49. We take square root because of power half. When we take square root at that point, it will be 1 over 7. Yeah, it will be 1 over 7. Then now there is a general power of negative 2 over 3. We are still narrowing down. This is going to be 25. Then we add 12. Sorry, it's a multiplication, 32. So 5 by 5 is 25, and 8 by 4 is 32. Then we add 1 divided by a 7. 1 divided by 7 becomes 7. Then there is now power negative 2/3. Yeah, negative 2/3. Can we simplify further by taking 25 plus 32 plus 7, which is 64. So in the brackets, we have 64. But now outside the brackets, we have a power of negative 2/3. So at this point now, we can talk about before the fractional law, the negative indices, the negative law of indices, whereby we have to take the reciprocal, then the power now becomes positive. And from this point, we can apply the fractional law now, whereby we need the third root of 1/64. Then after this, now we'll be raising everything to power 2. So the third root of 1/64 is 4. Yeah, so we get a quarter. We get a quarter squared. Which is 1 out of 16. This becomes the final answer in that procedure. The final answer. That becomes the final answer. So I hope you're getting it right. I hope you're getting it right. That's how we just play along with the laws of indices. Some of the problems might look complicated, but when you just begin solving them with a lot of confidence and with the knowledge of the laws, you discover how simple they are. Just discover how simple they are. So that is it. We can check one more question on the same. One more question on the same. And that is going to be, let me prefer solving number 13 with you people. Yeah, number 13. For me to solve number 13, I will need to again clear up the space. Remember, the laws that we're going to apply are the laws that we just listed at the beginning of this lesson. All of them. That is what we are trying to integrate together. We see which law is most suitable for which problem. After this, I'll be looking at a index equation, indicial equations, which I hope, again, through that, we're also going to be together. Number 13. You can allow me deal with the numerator first. Allow me simplify numerator for this one. Let me first deal with the numerator. Let me deal with the numerator first. Now, with the numerator, we'll be talking about 27 power 2/3. And you know, there I have to apply now the fractional law, which interprets itself as the third root of 27, then squared. The third root of 27, then we shall square. Multiplied by, or is it divided? Yeah, we're dividing that. Sorry. That's a division. So we have to be very careful. Divided by. Now the next is 32. Now, because of a negative 3/5, we should take what we call the negative law of indices. We make it 1/32. Then the power becomes positive. 1/32. Then the power is now 3/5. Yeah, the power is now 3/5. Let me finish up with the numerator first. The third root of 27 is 3. And when you square, you get 9. Divided by. Now we apply again fractional law, whereby we need the fifth root of 1/32. The fifth root of 1/32. This one should now be cubed. So we will have 9 divided by the fifth root of 1/32 becomes half, and half power 3 becomes 1/8. This will be 9/8, and this is going to be 72. We have 72 from the numerator as the most simplified. So the numerator is giving us 72. What about the denominator in that case? There are some of the laws which we had not applied. We're going to see them at this point now. we have the sixth root of 64 divided by 729, then everything raised to -1/5. So at this point, we have to talk about, let's apply the sixth power first of 64, whereby we'll be talking of 2 power 6. Yeah, so the sixth root of 64 is 2. The sixth root of 64 is 2. Divide by the sixth root of 729. That's going to be 3. Then everything now is to power -5. Yeah, that is from the first term. Then multiplied by 45 power 0. That's multiplied by 1. The 0 index. Everything raised to power 0 becomes 1. Everything power 0 gives us 1. Power 0. Everything power 0 is 1. Then multiplied by the square root of 16, which is 4. 16, which is 4. Now, to work out the first point here, we need to take the reciprocal. 3 out of 2. Then we raise to power 5. Then we will be multiplying everything now by 1 by 4, which is just by 4. This is going to be, need 3 power 5. Which is 243 divided by 2 power 5, then multiplied by 4. Now this is going to give us 8 by 4, 1 by 4, 8. So 243 out of 8. This is from the denominator. Now we can combine 72 from the numerator divided by 243 out of 8. Yeah, 243 over 8, which means 72 multiplied by 8 out of 243. This is going to give us 72 by 8 divided by 243. And this is going to give us 2 and 10 over 27. 2 and 10 out of 27. I believe I have computed that one well. You can as well confirm using your own calculator. Kindly confirm the last step for us, but this is what you should be working with. There is number 14, there is number 15, and there are other questions there that we didn't do. Kindly check all of them. Kindly check all of them. At this point, allow me work on solving indicial equations or equations involving indices. Equations that involve indices. And we're going to again solve a few. And after the solution of a few, I will also leave some for you to attempt. Number 16 is the first question in this particular category. Yeah, number 6, whereby we are talking of solve the equation 2 power x plus 2 equals to 4 and 2 raised to a half. Okay, let's put everything to the same base. Actually, the concept of expressing any composite number to the common base provided is what guides a student through the indicial equations. So in the first case, we are having 2x plus 2. I'm solving the first question, equals to 4, which is 2 power 2, multiplied by the square root of 2, which is 2 power half. Yeah, 2 power half. So we have 2x plus 2 equals to 2. And you just add the powers according to the first law. 2 raised to 2 and a half. So at this point now we can say because the bases are the same, then we equate the powers. X plus 2 equals to 2 and a half. To remain with x, you subtract 2 from the other side. The value of x becomes a half. Some of them are very simple. In as much as they might look challenging, when you start engaging, you discover how simple they are to deal with. So just have the confidence and understand that it is very easy to work out some of these problems. Very easy to work them out. So please follow up. Yeah, please follow up with the questions. We can solve one more. Solve one more. That is number 17. We can look at 17, then we check at a different question like, yeah, I'll choose several for you. But at 17, we have 27 power t. 27 can be brought into the least base, which is 3 power 3. Then there will be t there, divided by 3 power t minus 1, equivalent to 3 power 1 multiplied by 3 power half, because of square root of 3 power half. So we can, again, at this step, we can use several methods. This is division, so I can choose to subtract powers, and I pick 3, then 3t minus t minus 1 equals to 3, and I add powers there, 1 and a half, because this is 3 power 1. So at the left hand side, I'm subtracting powers. To the right, I'm adding powers. This is going to be, okay, because the base is now 3, we can just equate powers. 3t minus t, but that one becomes a plus 1, equals to 1 and a half. So with this, we can talk of 2t being equal to, is this not a half? Yeah, when 1 is subtracted from the other side. So to remain with t, now we have to talk about a quarter. To remain with t, we have to talk about a quarter. So the value of t is a quarter. And that is it. Nothing much, nothing less. A very good question in number 21. Please try out the other questions, but let me look at the interesting item in number 21. Yeah, number 21. So in number 21, we have 27 divided by 8, x plus 7 equals to 4 over 9 negative 3x. We can look at a common power, which might be raising some bases. The bases might be different in the composite numbers, but they can be raised to the same power. A common power. For example, 27 is 3 power 3, and 2 is also 3 power 3. So we can say 3 out of 2, everything there power 3. This will give us 27 over 8. Then out here, we already add x plus 7 equals to, we do the same for the right hand side where there is 4 out of 9. So 4 over 9, it can be 2 over 3 and everything squared. So 2 over 3, then we square everything, but there is already an existing negative 3x. Yeah. So to work out this, it will be 3 out of 2. 3 out of 2. This being raised to 3x plus 21 equals to 2 over 3, and we get negative 6x. Negative 6x. Yeah, negative 6x. Now with negative 6x, we need now to apply the negative law of indices, whereby 3 out of 2 remains 3x plus 21. This is equivalent to, we take 3 over 2 and the power becomes positive. Yeah, 3 over 2. We take the reciprocal and the power becomes positive. The laws we were just applying. At this point now, let me equate the powers. 3x plus 21 being equal to 6x. To remain with 21, we can have this one being 3x. Yeah. So that the value of x becomes exactly 7. Divide by 3, both sides, you get 7. Let me check at this particular type of setting. The setting in number 29, then we wind there. You will finish up with the other questions. In number 29, 9 can be put to base 3. And that will be 3 power 2, also plus 2, because power 2, the 2 multiplies x and 1 here, plus 3 power 2x plus 1 equals to 36. 36 cannot be put to base 3. 36 cannot be put to base 3. But now at this point, we can apply the first law, whereby we said a power m multiplied by a power n is just a power the sum. A power the sum, which means this is a 3 power 2x multiplied by 3 power 2, then plus 3 power 2x multiplied by 3 power 1 equals to 36. From the first case, this is 9 multiplied by 3 power 2x. From the second case, we have 3 power 2x equals to 36. Yeah, equals to 36. Now, 3 power 2x is appearing severally, so we can let 3 power 2x be a certain unknown, say even t. So 9t plus 3t equals to 36. So 12t is equivalent to 36. And to remain with t, we have to divide by 12, so that this becomes 3. So the value of t is 3. But what had we let to be t? What had we let to be t? 3 power 2x. So 3 power 2x is now 3, which is power 1. And we can narrow down to the powers now, 2x becoming 1, so that the value of x becomes automatically half. So that's another indicial equation, which is supposed to be seriously understood. Okay, we have the application of indices in other topics. This one is something unavoidable. Apart from working out indices in numerical cases, in algebra, in equations, we're supposed to know that indices can be applied in other topics. Indices can be applied in other topics. You see, this is even a question from sequences and series. We have variables here. We have stories to do with coordinates there. Yeah, so let me begin with number 41, which I'm going to show you. Then I give you time to try out the others. I'm going to introduce some logarithms in this question. When you try to read it out, you discover that we're being told that the points 2, 14, and 6, 126 lie on the curve with the equation y equals to ax plus ax power n. A and n are constants. Find the values of a and n. So when you introduce logarithms here, you discover that, okay, there might be other ways of solving this, but allow me to say that the log of y is equivalent to the log of everything here, ax power n. And according to the laws of logarithms, we know that the right hand side can be split into the log of a plus the log of x power n, which further can be brought down to the log of y equals to the log of a plus n, the logarithm of x. With this equation now, and we have two coordinates, then we can substitute. I want to look for some space. Can substitute and say the log of 14, because the coordinate here means y is 14 when x is 2. So the log of 14 equals to the log of a plus n, the logarithm of x, which is 2. And we use the other coordinate to also get another case for the same. The log of 126 equals to the log of a plus n, the logarithm of x at this point is 6. Yeah. So now that the log of a is appearing on both sides, we can eliminate log a, whereby when you subtract downwards, you have eliminated log a. And now you can take log 6 minus log a, log 6 minus log a, log 6 minus log 2. This is giving us 0.4771 n equals to, on the other side, the log of 126 minus the log of 14. Log 126 minus 14 so this I'm getting 0.9542. So that remain with n. Now we have to divide this 0.4771, and I'm getting exactly 2. So the value of n is 2. If the value of n is equal to 2, what about the value of y? What about the value of a? Because the two constants we are getting are a and n. So y equals to a x power n. Using the first coordinate, 14 equals to a, then 2 power the value of n. You know x is 2, then the value of n has been found as 2. So this will be 14 equals to 4a. To remain with a, we will have to remain with, by dividing through by 4, 3.5. Remember that the best way of purchasing airtime from any network is through the M-Pesa. You go to M-Pesa, the pay bill number is 737356. The account number is the phone number that you'd like to purchase airtime for, regardless of the network, Safaricom, Airtel, Telcom. Then after you've entered the number, now proceed to enter the amount, complete your transaction, and you shall have airtime reflecting instantly. Otherwise, thank you so much for following up with the lesson. Remember to invite friends so that they may also benefit. Thank you so much.